morning to all my dear friends, my dear students and the viewers. I am Professor Ashwin Kuljale, Assistant Professor in the Department of Mechanical Engineering. Welcomes you all for the today's online lecture of Advanced Manufacturing Techniques, an elective subject of 8th semester Mechanical Engineering. My dear friends, today we are going to take the overview of most of the non-conventional machining processes, the advanced manufacturing technique machines, right? So we will quickly revise most of the non-conventional machining processes. As we can see, the distinguishing parameters in between the conventional and non-conventional machining processes. My dear friends, in previous video we have deeply gone through the distinguishing parameters. See, for the advancement in the technology, it is the recognition of need, right? Now here you can see on your screen, it is the electrical discharge machining. It is shortly abbreviated as EDM, or else it is also known as the spark erosion machining process, spark machining, thermal erosion, or electro erosion processes. Why those different titles being given to particular this process is like the collection of spark, and due to the spark erosion is taking place onto the surface of workpiece, and how it is happening, and of course with the help of electrical discharge only, right? So let us see quickly how the electrical discharge machining process works. The principle of electro discharge machining is the spark is taking place in between the positive and the negative electrode. Here you can see the workpiece is being given positive charge, whereas the tool is given negative charge, and you can observe closely the gap is maintained in between workpiece and the tool. That gap will result into the formation of spark, and generally the gap is maintained between the workpiece and the tool is usually 0.01 to 0.5 mm, and you can observe it is dipped into a dielectric fluid, right? That dielectric fluid will carry the dissociated ions, the dissociated atoms along with it, and an arrangement of pump and filter will clean the dielectric fluid. The another setup you can observe here is the servo control. That servo control maintains the gap between tool and the workpiece, and of course the DC source of power supply, right? In the right hand side you can observe the zoom section of workpiece and the tool and the spark, right? Here in this process the dissociation of atom is taking place, right? The main attraction of ADM over conventional machining is that this technique is thermoelectric process to erode the undesired material from the workpiece. Now the construction part, as we have seen and observed, the setup consists of shape tool. The shape tool is the required dimension of the workpiece, isn't it? And accordingly the shape is given to the tool. Then power supply source, dielectric fluid and its circulation line, servo control tool feed mechanism to maintain the gap between the tool and the workpiece, and of course workpiece and One thing which should be mentioned importantly is the dielectric fluid that plays vital role. Now here in this process, tool is given negative charge, which is a cathodic one, and consequently workpiece is given positive charge, nothing but the anode, right? The terminals are connected to DC power supply to create potential difference between work and the tool. The distance between work and tool is known as spark gap, and it is filled by dielectric fluid. As we have observed, the setup is generally immersed into a huge tank or into the reservoir wherein substantial quantity of dielectric fluid is present, right? Now the working, I'll give you one reference to understand the working of electrical discharge machining is right. Whenever the fuse occurs at our homes, how and why it happens whenever the positive terminal of the wire of the cable comes in contact with the negative terminal, the fuse occurs, right? This principle is utilized in the electro discharge machining process. High voltage power supply is given to the workpiece, is given to the tool, which we observe negative terminal is given. But here we are maintaining the gap between workpiece and the tool, due to which the spark will take place, and in controlled parameter in the presence of the dielectric fluid, the dissociation of atoms, dissociation of ions will take place, right? The high voltage is applied between the terminal and it induces electric field in the spark gap. The free electrons on the tool are subjected to electrostatic force, and hence they are emitted from the tool and accelerate towards workpiece. There would be collision between electrons and molecules in dielectric. It causes further generation of electrons because of ionization of dielectric molecules. Right. This was the main working principle behind the EDM. Shortly, you can observe the process parameters as the voltage of ranging from 40 to 300 volt, current 0.5 to 400 ampere. The spark gap, nothing but the gap in between the workpiece and tool, is maintained in between 0.0125 to 0.125 mm. The pulse duration is from 2 to 2000 microsecond, and material removal rate is ranging from 800 to 5000 millimeter cube. Applications, wide range of application of electro discharge machining is there, like ADM drilling to drill very small holes, and EDM milling to machine complex shapes. My dear friends, with the help of electro discharge machining and a similar kind of process is there like electrochemical machining, those processes are generally used to super finish this workpiece. That it means very fractional quantity of material is removed from the surface of the workpiece. EDM can be used to make parts with irregular shapes with precision for forging press tool, extrusion dies, cutting tool dies, and many more. Now, one further advancement in the electro discharge machining is like wire cut electro discharge machining, wherein some alteration in the arrangements in the construction of this process, you can observe here the workpiece is not immersed into the dielectric fluid, but rather than it is supplied externally through the dielectric fluid sum with the help of a pump over the workpiece, and that will carry forward, that will eliminate the dissociated molecules, right? The wire feed electrode discharge machining process, wherein you can observe a wire is being supplied, wire with full tension having stressed over the workpiece is being supplied, and that wire in the presence of dielectric fluid will remove the material with the same principle as that of electro discharge machining. Right here you can observe the guide roller. Those rollers will play the role of keeping the wire in tension, in stress, right? If it is not there, the effectiveness of wire cut EDM will get reduced. And of course, the wire take up mechanism, that continuous spool through to pass through the wire cut EDM. The construction part of wire cut EDM, it consists of numerical control unit to control the counter movement of the workpiece, wire feeding mechanism to move wire at constant tension, power supply and dielectric fluid supply that we are supplying externally, right? The wire of diameter ranging from 0.02 to 3 mm is utilized in this process, and here also the tool is given negative charge, which is a cathodic one, whereas workpiece is given positive charge, which is an anodic one. Further, the process is similar to that of EDM process. The spark is taking place in between the wire, that is cathode, and the workpiece, which is nothing but the anode. And due to the spark, dissociation is taking place, and the dissociated molecules being carried forward with the dielectric fluid, right? Here we can observe the advantages and application of wire cut EDM process. With the help of this process, we can produce intricate components for electrical and aerospace industries. Very complex shapes can be machined with the help of this process. Machining of sheet metal die, extrusion dies, and prototype parts are produced. Cylindrical objects are also cut with the high precision, with high accuracy, right? Now we will look into the laser beam machining process. It is the thermal metal removal process wherein a beam of high intensity is impinging onto the surface of the workpiece. The laser, the acronym of laser stands as light amplification by stimulated emission of radiation. With the with the help of laser, we can perform several operations. This process is fully numerical controlled one, and with the help of which we can produce intricate machining, complex machinings can be done. Right. Now let us look into the working principle and the construction part. Here you can observe a ruby crystal is there at the central portion. That ruby crystal is uh, nothing but the aluminum oxide, which is doped with the chromium ions. Some around 0.05% of chromium ion is um, doped into the ruby crystal. One portion of this ruby crystal is uh, kept partially reflecting, and another one is kept as completely reflecting one. Monochromatic source of light is allowed to pass through it. As soon as we connect this system to the power supply, with the presence of monochromatic source of light, the chromium ion will get excited. That will result into the oscillation of chromium ions into the ruby crystal. That oscillation will go on with the continuous supply of power. It will oscillate into the crystal, and after achieving sufficient kinetic energy, it will emerge out of the partially reflecting surface. And you can observe here a lens is kept at the outer periphery. It will strike onto the lens, and that lens will concentrate the beam onto the workpiece, and that beam will actually perform the machining process. Right, here you can observe the construction part consists of cylindrical crystal ruby tube, which is nothing but the aluminum oxide, flash tube, which is nothing but the source of monochromatic light, focusing lens, power source, total and partially reflecting surface, mirror ends, and the cooling system. Ruby crystal with 0.05% chromium is doped here, and its one end is blocked with a total reflecting mirror. That arrangement is meant to allow the chromium ions to oscillate in the ruby crystal. After achieving certain kinetic energy, it will emerge out of the partially reflecting surface. Right? Measuring machining process parameters: voltage ranging from 4500 volts, pulse duration is 100 microsecond, material removal rate is 0.1 cubic millimeter per minute. The surface finish achieved is 0.5 to 1.2 micrometer. The application of laser beam machining: we can perform drilling, metal cutting, and even though welding process. In next video we will look into the laser beam welding process also, and along with this we are having another similar kind of process like electron beam machining process. It is most advantageous process. Now let us see the disadvantages, the lacuna of this process. It can't be used to drill deep holes. Why? Because the concentration will get loosed with the depth, and that is why it is not much effective in the depth portion. Highly reflective material can't be effectively machined if the surface of the workpiece is highly reflective. A steel with total reflecting surface cannot be machined. Why? Because it may reflect back to the it like an emission, like so. This cannot be performed onto the highly reflective materials. The initial investment is high. As we can observe the setup, crucial materials are utilized, so we can conclude like its initial investment is high, and safety measures must be kept here in this process, and skilled operator is required. Right. In next video we will continue the same presentation from the electron beam machining and other non-conventional machining processes. Till then, thank you for your valuable time, and I again thank you all. on behalf of the Department of Mechanical Engineering of Backward Party Group of Institutions. Thank you.